So Mitsubishi Electric is enabling Industry 4.0 by offering a range of edge technology solutions. So we're trying to link the OT layer, the operational technology, through to the information technology with the use of different edge computing technologies such as MES or C application server, which allows you to write script languages to pass data up into the cloud. At the moment, we see a lot of hype around Industry 4.0 of people wanting to implement the technology but not really understanding what it can do for their business. So we're really trying to just educate people of how they can collect information from the shop floor and really put the foundations in for Industry 4.0 with networking and architectures before moving it up into the cloud. What we're saying is do the groundwork first and then worry about the cloud later. I see Industry 4 as changing the way of robotics in a couple of different ways. Firstly, you're seeing a lot of more collaborative technologies. So for instance, here I have a robot system, and when I break the light curtain, I can actually stop the robot process in a safe manner. And when I remove my hand, it will continue. So it's a semi-collaborative robot. We're also seeing a lot of artificial technology starting to come through, where the robots themselves are sort of diagnosing issues before they've become major problems in the process, and therefore notifying somebody or fixing its own problem before it's actually become a production issue or stopping production. We've noticed the change in conversation with our customers really just around what is Industry 4 and what can they do to implement it. We've also noticed a big change in the way people are trying to implement robotic technology. They now want humans to work alongside a lot more with robotics. The biggest problems potentially of Industry 4 really are coming down to overhype, where people are expecting too much from the technology too soon. We're really still on the very early stages of adopting this technology, so we don't want people to kind of start implementing it and then get the wrong idea of what's going on and therefore fall over the first hurdle. So what we're saying is if you start slowly with a small project, clear focus goals, try and be smart regarding what you're doing, and therefore you can justify what's going to happen in the rest of the system once you've proved it on a small part of your process or application. Well, what we're seeing is a lot of sort of artificial technology start to be embedded, where you can start linking together sort of the simulation side and also the physical side. So you're getting a cyber-physical relationship between what's going on the plant with what's the ideal situation that's going on the plant, and trying to link the two together. So again, a lot of the technology we're investing is regarding cyber-physical systems, so you can start modelling what should be happening on the process, make changes in the cyber-physical world and see how they affect your production before you've made that process in the real life. And vice versa, if something's going wrong on your production environment, you can check what should be happening in your cyber-physical model and therefore make the right corrections at the right time to resolve those issues that's occurring. Again, I think the biggest barriers we have regarding Industry 4.0 is really knowledge and expectation from the customers' sort of higher management of what's actually possible and achievable. Well, we're expecting to see a lot of edge computing technologies start to emerge. We're part of a consortium called EdgeCross, and what you'll find is a lot of technology coming out regarding that, of capturing data and moving data around the production environment up into the information technology layer.